everyone, welcome to today's lesson. Today's lesson has to do with problem type number 4. Okay, this is the last problem type. Okay, and this I would say is probably the more challenging one. It's still definitely doable though. Okay, so we are going to we're gonna do what we did either in problem type 3 or 2, where we can add logs to both sides. So remember, I taught you guys that if you guys have something like log base 10 of x equals to log base 10 of 5, because there's one log on the left of the equal sign and one log on the right of the equal sign, you can cancel and you can therefore get x equals to 5. Okay? Now you can also go backwards, and if you start with x equals to 5, okay, you can also add logs, okay, to both sides. Log, okay, you can add one log on the left, one log on the right, okay. Now, this is going to be the starting point to this problem. We're going to add log to both sides. We're going to do log base 10, okay, all right. And then remember, if something is an exponent, you can move it over to the left. Okay? You can move it over to the left. Now, as of right now, this is what we have. Okay? We have 2x plus 5 log of 8 equals to 3x minus 7 log of 5. Okay. Now notice that I did not put the tens here. Okay, notice that these little tens right here, right over here, I did not put there. If there's no little number here and here where the two yellow highlights are, it's assumed that it's 10. Okay, so if there's an invisible little number here, if it's you can't see it, it means that it's a 10. Okay? Now if this were 9 and 9 up top here, then you need to write the 9 and 9. Okay? And if it's 8 and 8 and whatever, you need to write 8 and 8 and whatever down here. But if it's 10, you can leave it invisible. The same idea goes for, you can write 1x or you can write just x, because if you write x, the 1 is invisible. Just like if you write nothing on the bottom here, the 10 is invisible. Okay? And that goes for all problem type 4, all the problems that have to do with problem type 4, I'm gonna leave it invisible here because we're going to be using log base 10. Okay. Okay. Now I'm going to get all the x's to one side and all the y's to the other. Excuse me, all the non-x's to the other. So here's what I mean. This is times. Okay. So what I'm going to do is I'm going to move this 3x minus 7. Okay, and remember there's parentheses here. There's invisible parentheses. I'm going to move this 3x minus 7 over to this side. And how do I move it? What's the opposite of times? Is divide. Okay, and that cancels, and what you do on one side, you got to do to the other. Okay. Now, so far, we got all the x's here. Okay. We have all the x's here. But then I want to also move the logs to one side. Okay, so I want to move all the logs here. Okay, so all the logs on the right side, all the x's on the left side. I achieve moving all the x's to the left side. However, I need to move all the logs to the right side. Okay, so let's move this over by dividing, okay, by dividing by log 8. And what you do on one side, you have to do to the other. Okay? So as of right now, I have all the x's on the left. I got all the logs on the right. Okay? All the x's on the left, all the logs on the right. And by the way, you're going to go on Google and do online calculator. Okay? And let's do log of 5 divided by log of 8. Divided by log of 8. And you're going to get 0.77. Okay? So this is equal to, through the online calculator, 0.77. Okay? So as of right now, this is what we have. 2x plus 5 over 3x minus 7 equals to 0.77. And I'm going to put an over 1 here. Okay, over 1. It's an invisible 1 here. Now, from here on out, this is very straightforward. This is once you get to this step, you're pretty much home free. This is like IM1 stuff. Okay. Now, you ask yourself, you want the denominators to match. So you ask yourself, what is this missing that has? Well, this is missing a 3x minus 7. And remember, what you do on bottom, you got to do on top. Okay. Now, do our denominators pretty much match? Yes, they pretty much match. Okay. This is missing a 1, but that doesn't matter. It's invisible. Okay. So our denominators match. So now we can actually ignore our denominators. Okay. And just focus on the top. Okay. I can ignore the denominators now. Okay. So now what I got is, if I just focus on the top, I get 2x plus 5. And let's distribute this. Okay. 0.77, you can use your online calculator again, times 3 is 2.31. And then let's multiply 0.77 times negative 7, and you get minus 5.39. Okay? And we're almost done. Now you have a classic situation where you have x's on each side of the equal sign. You have x's on each side. I like to pick the smaller one. Okay, I like to eliminate the smaller one. The smaller one is 2. Okay, 2 is smaller than 2.31, so I'm going to go minus 2x, minus 2x. Okay, and as of right now, I get 5. Okay, I'm gonna move it up here now. Okay, as of right now, I get 5 equals to 0.31 x minus 5.39. Okay. And now I'm going to add, I want to get the x by itself, so I'm going to add 5.39 to both sides. Okay. So plus 5.39 cancels, plus 5.39. Okay. And then you get 10.39 equals 0.31x. Okay. And final step is you divide both sides by 0.31, divide it by 0.31, and you get x equals to 33. Okay. Let me just double check that. 33.52. Okay. X is going to equal to 33.52. Okay. So folks, I think the hardest step is just these first two steps here. Okay, you log up both sides. Okay, and remember, I'm not gonna put these little 10s on the second step because it's already understood that if it's invisible, it's a little 10. Okay, I'm gonna move the exponents over. Okay, and so we get to this black here. Okay, this black right here this step right here, I should say, looks kind of confusing, but it's actually very straightforward. We're basically doing what we have to do to move all the x's to the left and move all the logs to the right. Okay, so I divide both sides by 3x minus 7, which cancels here, and I divide here by 3x minus 7. Okay, and then to move all the logs to this side, I divide this side by log 8, which cancels here, and divide this by log 8. Okay, and I hit this up on my online calculator, and I get 0.77, and that's how I arrive at this black. And then you ask yourself, remember there's an invisible 1 here, and then you ask yourself, what is this missing that has, and it's a 3x minus 7. Okay, folks, I want you to go ahead and do these problems here. Okay, and I'll show the work for 11 and 13 and the answers. I'll actually show the answers for all of them, but I'll only show the work for 11 and 13. Okay, thanks. That's all, folks. Thanks for tuning in.